Hi everyone, here's a quick demonstration of a simple-ish log question where we note first of all that all of our logarithms here are to base 5, same base. So let's just have a quick reminder of our logarithm laws. So the one I think, or the ones that we really need to think about are the first and the second one here. If we have logarithms to the same base and we're adding together these logarithms, then it's the same as if we were to have the logarithm and we multiply the two terms x and y. Remember, logarithms are really indices, and when we multiply two numbers together with the same base, we add their indices. Likewise here with the second one, if we are subtracting two logarithms, then it's the same as the logarithm of the x divided by the y, these two terms, for the same reason. When you would divide terms that had the same base, you would subtract their indices. So let's see if we can apply those rules over here. Now, I note that all of these are the same base, so I should be able to write this all as a single log to base 5. And the 10 adds to the, when I say 10 adds to the 4, it's the logarithm of 10 adds to the logarithm of 4. So it's really the same as if I went 10 multiplied by 4. I still have here minus log of 5, base 5. And then now I've got a subtraction. So it would be the log to base 5. Now 10 times 4, that's 40, and I would divide by the 5 from over there. And this simplifies to the log of 8, base 5. Now, there's no simple way to get the answer for this without using your calculator. When the question, this particular question, it said simplify, that's where I would stop, because that's the simplified version of what we started with. If we wanted an exact answer, we're going to need a calculator. Now, I could estimate, of course, 5 to the power 1 is 5. I'll start even further down. 5 to the power 0 is 1, and 5 squared is 25. Now, my number 8 sits in here somewhere, so the answer to this on a calculator would be somewhere between 1 and 2, but that's about the best I can do without a calculator. I would stop there for this question, because that's simplified version of what you started with. Now let's take a look at another one. Perhaps the next one that I'd like to look at is slightly more complex, but applying the same ideas. So we've got 3 by log with base 2 of x plus log base 2 of x minus 2 times the log base 2 of x. Now this one, we notice that it's similar to the last, but we've got this 3 sitting at the front here. And for that one, we will apply our last logarithm law. When there is a constant number multiplied by a log, it's the same as if we had this as a power inside our logarithm. So let's go and do that part first. This would be the log base 2 of x cubed, where the number 3 at the front has become an index, plus log base 2 of x minus, now I'll do the same with this one, this will be x squared. The 2 from the front here has become an index on the x. Now it's similar to what we had last time. In fact, I might do these all together this time. So x cubed plus x, well that would be multiplication, x cubed, and of course it's a multiplication when it's inside a log. Silly me. And now instead of subtracting an index, it's dividing by the term, dividing by x squared. So what does this look like? That's log the base 2, x cubed by x is x to the 4th, divide by x squared, that's x squared. Now that's a reasonably good place to stop, but what did the question say? The phrase they used was express as a single logarithm. That is a single logarithm. That would be an acceptable place to finish. However, this little 2 here on the exponent could come to the front, and it could be argued that that's a simpler version of what we had because it's just the log of x rather than some function involving x. So I'd be very happy if you got to that point, and I'd be ecstatic if you got to that point there. So that's just a quick little demonstration of 2 examples of using our logarithm laws. And these logarithm laws over here, they're the backbone for all of these sorts of calculations that we do. Thanks for watching.